I can't wait for him to be able to do his presentation. So without further ado, here's Dr. Patrick Moore.
Thank you so much, Casey, and thanks to Seneca and the whole Seneca family for hosting my wife Eileen and I here in Eugene, where we've been before, but it's been a while, and so it's nice to be back. And we had a beautiful day. What a lovely fall day out in the woods with the leaves turning and a few birds singing. So thank you very much. I'm going to talk about why trees are the answer to a lot of questions about our future on this planet. And those questions range from the most practical of what we should build our houses with, what is the most sustainable and renewable material for doing that all across the country, to how do we preserve the land in a state that can support most of the biodiversity that came with it naturally, the deer and the bear and the insects and the birds and the shrubs and the herbs, etc., that grow in managed forests in the same way very much as they do in natural forests or preserved forests. So how do we do that? And then a whole range of subjects, but all the way to the most aesthetic as to how do we keep the earth green and beautiful. And trees are also the answer to that. You'll see what I mean. Before I get into forestry, which my family has been in British Columbia on Vancouver Island for over 100 years, this is why I learned quite a bit about trees at an early age. I grew up in that house on a floating logging village on the northwest tip of Vancouver Island until I was 14. I didn't realize how lucky I was to be in such a unique situation. There was no road to our village until I was well into my teens. And when the road came, we thought, wow, now this place is going to explode. People will come from all around. Half the people use the road to get out. So you learn something about human nature every day. But yet I didn't realize how lucky I was growing up playing on the tide flats by the salmon spawning streams. This is what Winter Harbor looks like today. And that's the view from our cabin that Eileen and I built when we first met 45 years ago. And this is the view to the south, and this is the view to the north. And that's just the place we love to go. But I had to leave there when I was 14. I was sent off to boarding school because my one-room school in Winter Harbor only went to grade 8. Sent to Vancouver, where I soon learned city ways, excelled in the sciences, the life sciences in particular, and ended up at the University of British Columbia studying biology, biochemistry, genetics, some forestry. And then in the mid-1960s, at the height of the Cold War, and the height of the Vietnam War and the threat of all-out nuclear war and the emerging consciousness of the environment, I discovered the science of ecology, a word that had not yet been printed in a newspaper or magazine for public consumption. But environment was becoming a word that people were listening to. And I went into a PhD in ecology at this time, and then I heard about a group of people that was meeting to plan a protest voyage against, this is the University of BC, a protest voyage against US hydrogen bomb testing in Alaska, who were meeting in the basement of the Unitarian Church. And I joined them while doing my PhD and sailed on the first voyage of Greenpeace. This is me becoming a hippie radical environmentalist in the late 1960s. And here I am under the P on the first Greenpeace voyage to stop US hydrogen bomb testing in Alaska. We actually succeeded in being the spearhead for this movement, which had tens of thousands of people marching all across Canada and the United States against these tests. And in early 1972, President Nixon canceled the remaining hydrogen bomb tests in the series. So on our way home from Alaska, we were welcomed into the big house of the Namgis Nation at Alert Bay near my northern Vancouver Island home, where they made us brothers of their tribe. And this began for Greenpeace the tradition of the warriors of the rainbow. It's after a Cree legend that says one day when the skies are black and the birds fall dead and the waters are poisoned, that people all around the world will join together to save the earth. We named our ship the Rainbow Warrior, and I spent the next 15 years full-time on the front lines of the movement around the world. We next took on French atmospheric nuclear testing in the South Pacific. France was still detonating atomic and hydrogen bombs in the air in the early 1970s, sending radiation around the southern hemisphere. They were a little more difficult. It took a few years to drive these nuclear tests underground at Mururoa Atoll, but they kept on testing right into the 90s, and as late as the early 80s, under directions from President Mitterrand, French commandos bombed and sank our ship, the Rainbow Warrior, in Auckland Harbor, killing our photographer, the only fatality that occurred during the history of the organization. But eventually, these nuclear tests ended. It was after I left Greenpeace, in fact. Going back 10 years to 1975, here we are confronting the Soviet factory whaling fleet off the coast of Mendocino in 1975. That's me driving the boat in there, and my friend Fred with his 16mm camera filming it all. We put ourselves in front of the harpoon to protect the fleeing whales and filmed it and photographed it and got on TV all around the world because we were protecting these whales that were trying to get away from the boats. And this really made Greenpeace famous everywhere. And so the rest was history. The following year, here I am sitting on a baby seal off the east coast of Canada to protect it from the Hunters Club. The seal was clubbed and skinned, but this picture appeared in over 3,000 newspapers around the world the next morning. This and other direct actions eventually brought changes to the way Canada managed its East Coast seal herds. So why did I leave Greenpeace after 15 years on the front lines? Well, this is supposed to go like that. Why did I leave Greenpeace after 15 years on the front lines? We had begun with very strong humanitarian orientation. That's the piece in Greenpeace, to save human civilization from all-out nuclear war. As time went on and we focused more and more on whales and seals and toxic wastes and other issues of environment, the organization and the movement in general drifted towards basically saying that humans are the enemies of the earth. And I never believed that as an ecologist. I know that we all came from nature, just like all the birds and animals and plants on this earth. We evolved along with all the rest of life. We're all part of nature. And that is kind of the main lesson of ecology, that it's all one evolution on this planet, and we're all on the same time front. People think that humans are a younger species than the older species. We're all the same age. This is the year 2018. And all the living things on the earth today are on the same time plane. They all came from the same place, the beginning of life. And so we should think of it that way. We're all here together, all insects, birds, animals, and people on this planet. And sustainability is about trying to balance the environmental, economic, and social priorities, not to put one ahead of the other. But you can't just say all that matters is the environment and the people don't count. That just isn't a very useful approach to the problem. So that I couldn't live with. But the sharp end of the stick, I was the only director of Greenpeace International in the end by 1985, so around 15 years after we started, that had any formal science education. My fellow directors were either political activists, social activists, and entrepreneurs. Now you could actually make a decent living in the environmental movement, whereas in the beginning, for years, we were volunteers. And my fellow directors decided that because DDT and PCBs and other compounds which are chlorinated hydrocarbons are toxic, therefore the solution was to ban chlorine worldwide. And I tried very hard to talk them out of that idea because actually chlorine is one of the essential nutrients. We don't need every element to be alive. We don't need uranium, for example, to live. And many other elements are not needed for our bodies. But chlorine is one of the ones we need. Otherwise we would die. Like salt is an essential component of our diet. And I pointed out that chlorine is actually the 11th most common element in the Earth's crust. It's a natural thing. You can't just go around banning elements. And It's also was the most important advance in public health to add it to drinking water and spas and pools to prevent the spread of communicable disease. And it's also the most important element for use in making pharmaceuticals. Most of our synthetic medicines are made with chlorine chemistry. And the reason for that is precisely because chlorine is toxic to bacteria. That's the primary reason, and other disease agents. And so there's this naive myth that there should be a world with nothing toxic in it. Nothing toxic under your sink, nothing toxic in your medicine cabinet, nothing toxic in your factories, nothing toxic anywhere. That doesn't work, because we need to have things to protect our health from agents which are trying to kill us. And none of that all fell on deaf ears, and they passed the campaign to ban chlorine worldwide, and I had to leave. So it was a bigger story than that, and there's a lot more to it. But let's talk about trees. Trees evolved in the Devonian period, 350 million years ago or so, and the magic to trees evolving, a strong, tall stem, was the invention of lignin. Cellulose had been invented 3 billion years ago. Cellulose was nature's first plastic. Cellulose is a polymer, like polypropylene or polyvinyl chloride. Each one of those has a monomer. Polypropylene, the propylene is the monomer. What's the monomer of cellulose? What's its building block to make a chain? Someone knows. You just said it. Who was it? Did you say glucose? Yes, of course, that's right, but very few audiences have anybody in them that knows that. So what happened was plants took the product of photosynthesis, the primary product of combining carbon dioxide and water to make sugar, and linked them all together into a chain and made a polymer that then could be woven into a fabric to make cell walls and other membranes. It was a very important advance. But a string of cellulose is like a piece of cooked spaghetti. It has no strength to it by itself. When lignin was invented, it was kind of like the concrete to the rebar of the cellulose. So the cellulose is oriented this way, and the concrete is around it and gives the cellulose strength so that it won't break. Like a concrete pillar just won't break because it's got all these strands inside there. So it's like a reinforced pillar of concrete in that way. And then they started growing up, because before trees evolved, all plants were just sort of laying on the ground kind of limp, you know, like a liverwort. And trees changed everything. They are now, and have been since they evolved, more than 90% of all living biomass on Earth, and they therefore contain more than 90% of all the carbon in living biomass on Earth. If you think of a mountain around here covered in trees, how much that wood weighs, all those trees weigh. Doesn't take very many acres to weigh more than all the people in Eugene and all the critters in the woods. They are the main form of life on the planet. And they are home to the majority of all living species of insects, birds, plants, animals. A majority of species depend on forests for at least part of their life, for their survival. That's because the living trees themselves create a new environment. Rather than now just a flat, two-dimensional surface of the earth, you have this space that's inside this canopy where the environment is radically changed from what it was before. They shade the ground and keep it cool. The canopy of the forest above is now home to millions of insects, birds, and in the tropics, animals. Well, even here, there's a squirrel or two up in every one of those trees. So new habitat is created, and the fruit and the leaves of the trees now becomes food for a myriad of species. The trees provide an entirely new ecosystem that wasn't there in their absence if you just had flat ground. And even when the trees die, they provide a vast amount of nutrition for decomposers in the forest, and, as I mentioned, little guys like that wouldn't be there if it wasn't for trees. So this gives the concern that if you cut the trees down, all those habitats and homes will be lost for those species and they will die. Indeed, in 1996, sort of at the beginning of what we called the War of the Woods in British Columbia, the World Wildlife Fund held a media conference at a UN forestry conference in Geneva, where they said that 50,000 species are going extinct every year, and the main cause, read the second paragraph, commercial loggers are largely to blame, they said. You would think if there was 50,000 species going extinct and the main cause was forestry, they could name one of them. Never has a species been identified which is extinct due to forestry. There is no example. And yet, many species have gone extinct due to human activity. There are three primary causes. The first is outright overhunting and even purposeful eradication efforts. The dodo bird was hunted to death by sailors for food in the Southern Ocean. The passenger pigeon was hunted to death across North America. The Carolinian parakeet was killed by farmers because it preyed on their crops until there were none left. And way back in history, the large mammals that roamed North America when people first came across the land bridge from Asia were easy prey because they weren't fast enough to outrun a human being, because there'd never been any human beings over here. And so they just basically killed and ate them all. That is one of the main ways species have gone extinct through the years. Another cause is widespread forest clearance or ecology clearance for agriculture. There might have been a lily living in this place here where it didn't live anywhere else. And if you cut the trees down and everything else and plow it and plant it with pumpkins, you're liable to lose the lily. And that is a serious cause of species loss in many parts of the world. And then one of the more insidious are introduced predators and diseases. Snakes, rats, foxes, cats, etc. And especially on islands that were colonized by Europeans during their spread around the world, even big islands like Australia and New Zealand experienced large pulses of extinction as exotic species were brought to their shores. But to repeat to the best of our scientific knowledge, no species have become extinct due to forestry, including this one. The spotted owl caused a vast reduction in the use of forest management across the federal lands in the U.S. West, mostly voted on by politicians in the U.S. East who outnumber politicians in the U.S. West by a considerable margin, and they do so at no expense to their own electorate. So I've studied this politically fairly thoroughly and understand why it happened, but in fact, forestry has never been a factor in endangering the spotted owl. Urbanization, agricultural clearance, perhaps, but the spotted owl was never endangered with extinction because there's so much forest for it to live in the Pacific Northwest. It was just used as a symbol against forestry. This brings us to a very important fact. If forests were not capable of recovering from total destruction on their own, there would be no forests, because forests have been being destroyed by avalanches and windstorms and firestorms and glaciers and every imaginable other catastrophe since the beginning of forests. When those factors are stopped, when the wind stops blowing and the fire stops burning and the ice retreats, the forest grows back. If you go to Alaska, where some glaciers have been retreating for 200 or 300 years now, it only takes about 50 years for a fully functional forest to become established in the wake of their retreat. That is why species don't go extinct from forestry, because forests are capable of recovering without our help. They don't need us in order for themselves to be there. It's we who remove them on purpose to make farms, for example, and cities. So every species that lives in the forest must be capable of returning to areas of forest that are recovering from destruction by whatever means. Ecologists prefer to use the word disturbance instead of destruction because destruction is somewhat morally loaded, whereas disturbance is a kind of neutral term. You know, extensive disturbance is caused by huge wildfires, for example, and forestry causes considerable disturbance when you cut all the trees down, but nowhere near as much as a really hot wildfire does, which tends to cause more damage than that. Some species come back very quickly. They can fly, carrying seeds of plants that then also come back to the area when they poop them out. Fire has always been the main cause of forest destruction or disturbance around the world. And again, we come to the fact that fire is a natural phenomenon unless it's lit by a human being. But fire by lightning, in particular, is a natural phenomenon. It's been happening since the beginning of time. And it results in scenes like this. This is from central British Columbia. And not only does it kill the trees and all of the plants, but it sterilizes the soil in many cases and kills all the seeds that are waiting there to help rebuild the forest after it's burned. But you come back to a place like this 2 years later, as I did, and here's what it looks like. Everywhere in the world, there are plants that make seeds with fluff on them, dandelions and fireweed and all the rest, that can float for 100 miles on a light air, looking for a place to settle out and germinate in the open sun, because now the shade of the trees has been removed by the fire, and you have a sunlit landscape where these plants that came there on the wind can germinate. And there you see the fireweed, and the yellow flowers are ones that produce seeds like dandelions, which float around like a little parachute. If you want to see total disturbance by nature, Mount St. Helens was a wonderful example. I went there shortly after the eruption and filmed it from the air and filmed it from the ground. Here's what it looked like before it erupted. The whole lower slopes clothed in beautiful forest, some of it managed, some of it in federal parks and wilderness status. But here's what it looked like shortly after it blew up. Pretty barren, but you can already see the new cone building in the middle. That's going to come back up in another few hundred years and make Mount St. Helens look a lot like it did in the first place, because it's still volcanic. But the landscape was basically scoured clean by a 400-mile-an-hour blast of volcanic gas that came out that's so hot it burned everything and caused erosion, sheared stumps 4 to 6 feet in diameter right off at the base. It was so powerful. Some of that land was owned by Weyerhaeuser and other forest companies. They immediately reforested it with native species, and within 10 years, it looked like this. Here's the divide between the area that was reforested and the area that was not. Now, some people will say, why did they leave all those snags and that mess there? Why don't they clean that up and get a forest growing in there? Other people would say, why did they plant all those plantation trees there? Why didn't they let nature heal that place by itself like it would do anyways? So there's two types of people that way, who see it completely differently. Yet the funny thing is that those two together actually provide more biodiversity than either one of them does by itself, because they're different. And so they each provide advantages for different species in different ways. There's plenty of woodpecker habitat on the right-hand side there in all those snags. And insects and all kinds of species are going to take advantage of that. But on the other side, those trees are going to grow up quickly and provide habitat for species of birds that rather would be in the canopy of trees, and animals that would rather be in there than in the more barren place on the side. And this all leads to the fact that forest management done properly, creating a mosaic in the landscape of all age classes, of regrowth, taking into account biodiversity and the need to have other species coming in along with the one you're planting that's preferable to your forestry plans, can be more biodiverse than a natural landscape that's all the same all across it. Because there are species that have evolved to take advantage of every stage of forest regrowth, from recent harvesting all the way through to old-growth timber. Some species that will live in recently harvested areas will not live in old-growth timber, and vice versa. So managing the forest landscape for a mosaic in a sustainable way is actually capable, in many cases, of increasing the biodiversity in that landscape from what it was before. Not always, but sometimes. My grandfather, Albert, in 1930s, clear-cut this area. There was no replanting in those days. They made a hell of a mess because they had primitive equipment and they dragged the trees through the dirt and messed it all up. Today, without any intervention, just by letting it grow back by itself, there are bears and cougars and wolves and owls and eagles and ravens and deer, and all the other species are back in that forest again. All just because it was left alone. They came back by themselves. Switching gears. This is a very important point. In my book, I call it the aesthetics of comparative landscapes, how land looks to us. The way a landscape looks to our eyes, whether it's ugly or beautiful, should not be used to judge the health of the environment. Now, that's a hard thing to get over, because we judge landscapes and views by how beautiful they are, how good a postcard they would make if you want to take a picture of it. That is not ecology. That is aesthetics. That's art. That's a postcard. It's beauty. So beauty is in the eye of the beholder. Beauty is only skin deep, and you can't judge a book by its cover, are all sayings that try to educate us about that concept, the fact that we shouldn't judge people by how they look any more than we should judge landscapes by how they look. But the Sierra Club says you don't need to be a professional forester to recognize bad forestry. If a forest appears to be mismanaged, it is mismanaged. That is because they want you to judge the foreground of this photograph as bad, wrong, bad management, because it's ugly. But what is it really? It's just big pieces of burnt wood on perfectly fertile soil. And every bit of that second-growth eucalyptus forest in Western Australia in the background there looked exactly like that 20, 30 years ago, before this picture was taken. See, foresters in Australia discovered that the best way to get the Kerry eucalypt species to grow back thick and fast after harvesting was to come in and burn the whole place and then dig it up with an excavator and stir the soil like a farmer would do when they plow the field. And that makes it, the seeds, like that. And they come back into that beautiful forest in the background without any planting. That's natural regeneration from the seeds that were in the soil. Taken in the right light, clear cuts can actually look quite pretty. Think of the clear cut as a temporary meadow. It is meadow-like because the trees have been removed and now the sun can reach directly to the ground and foster the growth of plants and other species that could never have grown in the full shade of the trees. But it is temporary because it's not going to stay that way. This area is going to be reforested either by natural regeneration or planting and will soon be a beautiful forest again. Take this area. We think of those meadow-like areas as being pretty, but they are basically very low in biodiversity. They're too dry for trees. That's why there's no trees there. You see the trees in the foreground are on a stream. The trees halfway up the hill is where water is seeping out, and the trees on the top are where it's cooler and therefore moister. Whereas where the beautiful place where you want to have a picnic isn't a forest. It's just grass with a few herbs. Nowhere near as biodiverse, because it's basically a semi-desert. Whereas this, you don't want to have a picnic in there. Yet here, there are roots and seeds of every species that was there when it was logged. And when it grows back in 10 years, it looks like this, because all those seeds and roots were there, ready to come back. And they do so by themselves. Nothing was planted here. Deforestation. We talked about that today. People think that deforestation is just when you cut the trees down. That is only the first stage of it, and not the most important one. Deforestation is the permanent removal of trees from a landscape and its conversion to another use, such as agriculture, urbanization, factories, whatever. That's deforestation. The change in land use from forest to something else. But this is easily perceived as deforestation. A valley clear-cut across with just a little bit of green showing. It even looked less acceptable when the green hadn't come in yet. This has already been replanted. The trees are small, but they're there. So this is actually a scene of reforestation, not of deforestation. This is a scene of deforestation. It looks very pleasant, pastoral, neat and tidy, but all those farm fields were once forest. And if you left those farm fields alone for 5 years, seeds from the surrounding trees would come in and begin the reforestation of that area naturally. That's just a fact. That is deforestation. So we tend to think of pastoral scenes as being pretty, with a bunch of sheep grazing on grass across the landscape, when in fact you have a domestic animal on a deforested area going on there. And in Europe, in fact, where they had cleared so much land of forest, people opposed the bringing of trees back because it made it dark. They wanted the land to be open, like it always has been, they thought, possibly for generations. But it wasn't always like that. It was deep, dark forest all across Germany and France and Switzerland and all those countries until they cut all the trees down and turned them into farms. So deforestation is seldom, if ever, caused by forestry. It nearly always caused by the conversion of land to agriculture, urban development, and industry, by friendly farmers growing our food, nice carpenters building our houses and towns. It's not done by evil people. Deforestation is done in order for us to have our food and our accommodation, primarily, and transportation, too. What have we here so lovely in the late afternoon light but large lumps of dead cellulose sitting on a piece of deforested land? The biodiversity is all in the background in that rather nondescript-looking scrub there. But people like the picture of the hay bales with the light on them the way it is. Makes a good postcard, a good painting. But it's deforestation. This is a zinnia plantation in Australia, where the petals and flowers are kept perfect by regular spraying of insecticides, and there's only one species of plant growing there. In the background is a biodiverse native eucalyptus forest. Some of it is managed for timber, some of it's in preservation, but it's all naturally forested land with native species of trees. But that's not what draws the eye. Here, a wheat field blowing in the wind in the sun is a beautiful sight. You stop your car and wonder at it, how gorgeous it is, when it's total deforestation with an exotic species of plant. Whereas the recent clear-cut in the boreal forest looks like this and is the promise of a new forest very quickly and on a sustainable basis, with less timber being cut than is being grown in North America pretty well everywhere. The United States has the same or slightly more area of forest today than it did in 1900, largely because of intensive agricultural production being able to grow 5 times as much food on the same area of land as we could in 1900, therefore not requiring so much land to grow food, and therefore having more land to remain in trees. Intensive forest management does the same thing, grows more timber on less land, so we can put more land into preservation status as parks and wilderness. Land use planning and land use is the key to understanding all of this. You can't just look at one thing. You have to look at the entire landscape and talk about it in terms of what's the best use for this place, how much timber should we have coming out of here, how much food should we be growing, what areas should be preserved for preservation because they're beautiful or because they're special biodiverse-wise, etc. And then there's this. How many life signs are there? There might be someone in that van driving across the parking lot. It's interesting to note that transportation takes up way less land than it did in 1900. That's because back then 25% of all farmland was used to grow food for animals, to be used for plowing fields and carrying people and things. So transportation took up about a quarter of all the agricultural land. Whereas today it takes up less land, but it's pretty radical what we do to it. Consider that black stuff under the cars there. That's asphalt. Why is it legal to take the toxic waste from oil refineries, mix it with gravel, and spread it all over the landscape, killing every living thing? That's what roads are. That's what parking lots are. Next time you're driving down the highway, think of it as a ribbon of death before you. Right? It's a new perspective on roads. I'm not against transportation, of course, but we should get it into perspective. It's perfectly okay for huge fleets of dump trucks to go and pour this stuff onto the land to make our parking lots and roadways. And then nobody is chaining themselves to those trucks to prevent this from happening. They're all hanging from a big tree out in California, So, again, getting it into perspective as to land use and what we do to the land, what we need from the land, is the key. Forestry is the most sustainable of all the primary industries and provides the majority of renewable energy and the majority of renewable materials for our daily needs. That's a big mouthful, but it is true. Wood is the most important energy resource, especially in the developing countries, where they need to learn sustainable forestry. Some of them are not there yet, but many are. China has actually added more forest land by reforesting land that had been deforested than all the countries in the world put together in the last 20 years. They have this massive program of reforestation going on there. And other countries do too. And the tropical developing countries like Indonesia and Brazil are learning to do sustainable forestry. They have their own land use plans. But if you look at Indonesia, they are prepared to set aside 25% of their entire forest land base in protected forest. That has not happened in very many industrialized countries. Europe in particular, where very little percentage of their land is actually protected because they'd already unprotected it long before the idea of protecting large areas occurred to anybody. So when you think that forestry, of all the renewable industries, like what are the renewable industries? I sum them up in 4 cultures. There is agriculture for growing food on the land, animals and plants. There is silviculture, which is a fancy word for forestry, silvix. Silvatica comes from the word tree, for trees. So silviculture, growing trees. There is aquaculture, growing food in the water, fresh water and seawater. And then there is urban culture, where we grow people. That's the people farm. Of those 4 cultures, 2 of them pretty much eradicate the original ecosystem, agriculture and urban culture, food and people. But 2 of them, forestry and aquaculture, do not do that. If you have fish in a pen floating above the bottom of the ocean, all the species around it are still there, and under it too. As a matter of fact, crab and shrimp fishermen preferably set their traps near salmon farms in order to take advantage of the fact that the crabs and shrimp are benefiting from the waste from the fish, which is, after all, organic and feeds the sea. So That's another way of looking at it. And those are just the renewable industries. Which one of those is the most sustainable? I would argue forestry done properly is the most sustainable of all the four cultures, silviculture. Then there's the non-renewable industries. Fuel, oil and gas, coal, glassworks, metals, minerals, all the rest of it. Steel, concrete, plastic. You know, those are non-renewable materials. Which one of those is the most sustainable? That's an interesting discussion, but we won't go there tonight. The forests of North America are abundant and growing, I told you this. The environmental movement's policy is basically cut fewer trees, use less wood. That is not an environmentally appropriate policy. We should be growing more trees and using more wood. In this way, we use less steel, concrete, and plastic, which are perfectly good materials in their own right, but can be often substituted by wood, especially with the new technologies we have in laminated veneer lumber and particle boards and all kinds of incredible technologies for using wood to make strong things and durable things that can replace some of the non-renewables. So we should be growing more trees and using more wood, not cutting fewer trees and using less wood. That, to me, seems just plain logical. What do we do with all the wood we use? 60% of all the wood used in the world is burned for energy, mostly for cooking and heating, where 2.5 billion people depend on wood as their main source of energy, sometimes not sustainably, which is something that is important to be addressed. But that's got nothing to do with forestry in particular. It's got to do with basically getting enough firewood to stay alive on a cold night and cook your food. 20% of wood is used for solid wood products. All the available substitutes, steel, concrete, plastic, and them require far more energy to produce because trees are made in a factory called the forest by renewable solar energy. Here's what the Intergovernmental Panel on Climate Change actually says about forestry. In the long term, it takes them 38 words to say this. In the long term, a sustainable forest management strategy aimed at maintaining or increasing forest carbon stocks, that's what they call trees, forest carbon stocks, while producing an annual sustained yield of timber, fiber, or energy from the forest will generate the largest sustained mitigation benefit. In other words, is the best thing to do. Right? To grow more trees is the best thing to do. They say that in 138 words. My old friends in Greenpeace say the Intergovernmental Panel on Climate Change, the foremost peer-reviewed experts on climate change, says the easiest and cheapest way to fight climate change is to, quote, leave trees standing and protect its biodiversity, unquote. I challenged them on whether the IPCC had said anything of the sort. Their reply was, sorry, we didn't mean to put it in quotes. And that was the end of it. They never said anything like that. They just made that up. I say, grow more trees, use more wood. 6 words instead of 138. The IPCC is a typical bureaucratic nightmare. 20% of wood is harvested for pulp and paper products. Half of this is derived from sawmill waste, such as Seneca's sawmill, where the chips and sawdust comes out and goes to pulp and paper. The balance is from plantations planted for pulpwood. In the south in particular, the southeast, there are pulpwood plantations where the trees are grown especially to feed a pulp mill. But that is the exception in the United States and Canada. Most of the paper is made from the waste from sawmills. And people say we shouldn't be making paper from wood. We should be making it from hemp or some other fiber. Can you imagine bears in a hemp plantation? Hemp plantations will not provide the biodiversity that forests do. That is the beauty of forestry and sustainable management of trees, is by growing trees for the production of wood, we also provide the habitat for biodiversity virtually and close to the natural situation, and as I explained earlier, sometimes even enhancing it. Trees always provide more habitat for biodiversity than annual farm crops. Therefore, we should make paper from trees. I can't see any other conclusion to be drawn. Now, I'm going to go sideways just for a minute here because I give a very major explanation of climate change and energy in my speech these days, but I'm just going to show you a few slides to give you an idea about the relationship between forests and the climate issue, in particular CO2, which is the main food for all life on Earth. CO2 is not a pollutant. It is the primary food for all life. That is where the carbon in our bodies comes from. That is where the carbon in all life comes from, and all life is carbon-based. It doesn't come from anywhere else. It comes from CO2 in the air and from CO2 in the oceans and the lakes. That CO2 in the water was dissolved from the air into the water, absorbed by it. That's how it gets in the water. And there it becomes the food for aquatic species. If it weren't for CO2, there would be no life on Earth, period. Life would not have evolved unless there was a source of carbon that could be used by life. So that is a fact. Here is a graph going back 570 million years. It goes back another 4 billion years before that, and life goes back another 3 billion years before that. But this is the most recent information. This is the curve of global temperature. These are ice ages. These are very warm greenhouse ages, here and here. And here is the decline in temperature that has led to the Pleistocene Ice Age, the first ice age for 300 million years. It is colder now on Earth than it has been for 300 million years during this 2.5 million year Pleistocene Ice Age that we are in now. CO2 is represented by this purple line. Note that occasionally the temperature and the CO2 are in sync with each other, but not very often. Temperature rises rapidly, CO2 stays down. This was the CO2 being drawn by the development of forests that began in the Devonian, and the reason the Carboniferous is named this is because of all the carbon that was laid down as coal, which was basically all made from forests. So this was the height of forest growth at the beginning of forests when they spread all over the Earth and they sucked the CO2 out of the atmosphere. There's many reasons thought about why this happened so radically, but it drew it down, not as low as it has been during this ice age, but quite low. And then it recovered over a period of 100 million years. But look at here. Temperature goes down, CO2 goes up. Temperature goes up, CO2 goes down. That does not look like a causal relationship. Causal relationships require fairly tight correlation between the two factors, if indeed one is causing the other. And so right here with the 500 million year history, mostly deduced from sediment cores, you can see that CO2 is now lower than it has been in the history of the Earth, not just since 300 million years like the temperature. This was an ice age. The temperature now is in that same sort of range. But CO2 has steadily gone down, as opposed to temperature, which if you drew a line to represent temperature, would basically be fairly straight across like this, right about here. There is no trend in temperature, but there is a trend in CO2. I'm going to show you now this part. This was actually produced by James Hansen, who is one of the fathers of the climate change apocalypse theory, but he did it in 2008. And here is where we were at the Eocene thermal maximum. We are at the tail end of a 50 million year cooling period today. This is the Pleistocene Ice Age. Antarctic began to glaciate here. Prior to that, the Earth was ice-free for these 35 million years, and before that too. I mean, this arrow should go back 300 million years to the ice age that occurred before. So this is the downward trend in global temperature leading to the Pleistocene Ice Age here. We don't know why this happened. We honestly do not know. why the temperature went from this spike in the Eocene therm maximum. This is when the dinosaurs went extinct here, when the Earth was lush from pole to pole. Antarctic was a forest. The Arctic was all forested, all the islands of Canada were forested until here. This is when the forests of the Canadian Arctic islands turned into tundra and cold. Now I'll show you this bit right here. This is from the Vostok ice cores drilled by the Russians near the South Pole in the Antarctic ice. It goes back 400,000 years, approximately. The Europeans have drilled 2 holes that go back 800,000 years. They show this same pattern. These are the interglacial periods, one of which we are in now, here. These are the peaks of the major glaciations which covered the whole of Canada down into the northern tier states with a massive sheet of ice between 1 mile and 2 miles thick. Montreal was covered in 3.3 kilometers of ice during this time right here, and prior to that too. Notice how you go into the glaciation slowly and come out of it quickly. It's kind of a sawtooth looking arrangement. These are approximately 100,000 years apart, in sync with the Milankovitch 100,000 year period of the change in the Earth's orbit around the Sun from more circular to more elliptical. There are 3 or 4, depending on how you count them, Milankovitch cycles. That's the 100,000 year one. There's a 41,000 year one. There's a 20,000 year one. The Earth's tilt changes every 40,000 years. That changes the solar radiation on the northern and southern hemisphere. So temperatures change. You note that this is showing both CO2 and temperature. CO2 is the blue. Note how the CO2 tends to follow the temperature rather than lead it. If you take the databases from these ice cores, on average, CO2 comes after the temperature change by 800 years. That would indicate that the temperature change is causing the change in CO2 rather than the CO2 change causing the temperature to change. Why would the temperature change cause CO2 to change? Very simple explanation. When the seas, which cover 72% of the Earth's surface, get warmer, they give off gas. Just like when you take cold water out of a fridge and put it on your counter and it warms up, all these little bubbles form on the glass. That's the outgassing of oxygen and CO2 and other gases in the water, because warm water holds less gas than cold water. When the Earth cools, such as this way here, it sucks CO2 out. The oceans suck CO2 out of the atmosphere, and the atmospheric CO2 goes down. You see, here's what we've done. In a short time, we've changed it from 280 to 400. The temperature has not followed the CO2. If they were in lockstep, temperature should have spiked way up here somewhere instead of just remaining where it is. So this is pretty much accepted by most people who are not alarmists on climate. That in fact, what I'll show you now is this bit here, the Holocene interglacial period, which is this bit here. Here's the height of the last glaciation. CO2 fell to 180 parts per million as a result of being sucked out of the atmosphere by the oceans. And here it is coming back, following the temperature, not leading the temperature. It would be here if it was leading the temperature. It's following the temperature. And as the oceans warmed, CO2 went up to 280 ppm eventually, from 180. Here, at 180, almost certainly the lowest in Earth's history. Only 30 parts per million above the death of plants, which begins to occur at 150 ppm. So if we go back to here, this is what we are doing here. That is the effect of our CO2 emissions, mainly from burning fossil fuels. We are restoring a balance to a global carbon cycle that was in a one-way trip towards the extinction of life on Earth. That is a fact. This is a fact. And why did that happen? It happened because marine calcifying organisms evolved back here, which were capable of taking CO2 and calcium, combining them to make calcium carbonate, and building protective armor plating for themselves. Clams, crabs, shells, shellfish, coral reefs. Think how much carbon is in coral reefs, because it's all calcium carbonate that all these shells are made of. So the carbon has been sucked out of the atmosphere over the ages, and obviously if you have a decline, steady decline like this, CO2 is coming out of the atmosphere faster than it's going into it. Volcanism has reduced drastically as the Earth has cooled over the billions of years. So way less CO2 is going into the atmosphere now than was 2 billion, 3 billion, 4 billion years ago. That is my hypothesis, and I'm sticking to it. Here is the Holocene. Again, that is just this part, when it warmed up. Here's the temperature curve coming out of the glaciation, and this is the 40,000 year cycle of the Earth's tilt, and this is what has happened in the last 5,000 years. Temperature going down, while CO2 went up. This is from Greenland, ice cores. This is called the Holocene conundrum. Why is CO2 going up when temperature is going down? We don't know the answer. That's why it's called a conundrum. This shows the Holocene period back to 12,000 years ago, the advances of glaciers on the entire globe. The reason this period from 5,000 years ago to now, back here, the Holocene climate optimum, it was warmer than it is now. The Sahara Desert was green. There are petroglyphs out there that goat herders put on rocks. It was populated. We know where, you can look on the internet and find where the towns were in the Sahara, out in the middle of the desert, because it wasn't a desert. It was warmer and wetter. This was the breaking point here. 5,000 years ago, there was a sudden change. And during the Little Ice Age, there was more glaciers advanced than at any time in the 12,000 year period of the Holocene. That's why this is called the neoglacial by people who study this sort of thing. But you don't see this anywhere in the media. The last time the River Thames froze over was 1814. It had been freezing over regularly during the Little Ice Age here for 300 or 400 years. They were having huge festivals out in London, out on the ice. It hasn't frozen since 1814. We didn't do that. We weren't emitting enough of anything in 1814 to stop the Thames River from freezing. It was a natural thawing out of the Little Ice Age in the same way as it happened after the Minoan warm period 3,000 years ago, the Roman warm period 2,000 years ago, the medieval warm period when the Norse Vikings colonized Greenland 1,000 years ago, and all had left by 1300 AD because the glaciers came back. That's what happened in the Little Ice Age. This is the neoglacial. We are now slipping back like this one before us. This is called the Eemian interglacial. We are now slipping back into the 80,000 year temperature decline into the next major glaciation, if history is repeating itself, which it appears to be doing. So that is a rather different perspective than you may have gained by listening to CNN. Here is what happens when you double the concentration of carbon dioxide in the air around a tree. This is ambient, like it is now. This is basically doubling it, and these are intermediate stages. All these trees are under the same conditions. They're from the same seed stock. This is an observation and has been replicated over and over again and has been monitored from space for over 20 years now. And we know for a fact, and NASA has it on their website, if you go to the NASA website and Google greening of the Earth, you will find that we know for sure that the increase in CO2 is causing this greening. Everywhere that it's green means that forests and plants have increased 10, 20, 30%. And interestingly, it's the driest areas which have the greatest increase in photosynthesis. That is because increased CO2 does not only cause plants to grow faster and yield more agricultural crops and wood and everything else, but more CO2 makes plants more efficient with water. So in dry places now, plants have an easier time than they did at low CO2. And this is evident, I heard about it today actually, that the junipers that are spreading out over the grasslands all down inside the mountains in the interior of the coastal states, all the way down into California and Nevada, trees are invading what were grasslands because they now don't need as much water as they used to need in order to grow in those places. That is happening all around the world. It is a fact. It is poo-pooed. Somehow or other, the New York Times wrote, yes, the earth is greening and it is terrible. That was their headline. Terrible that the earth is greening. They just do not want to accept any other narrative than their own simplistic CO2 is the control knob of global temperature and also of all the storms and hurricanes and everything else. The IPCC report, which just came out, which you probably have all seen evidence of, that is saying we have 10 years left or 12 years left until Armageddon. Again, they're saying it. They said it 40 years ago, 30 years ago, 20 years ago, and 10 years ago. Now they're saying it again. And they are basically, though, very clearly stating that there is no evidence of increase in extreme weather events of any kind. They at least recognize that, because you can't argue with that. The statistics are there for at least over 100 years for hurricanes and tornadoes and floods and droughts. There is no increase in extreme weather events. There has been an increase in global temperature of 1 degree Celsius since pre-industrial times. 1 degree. And their aim is to make sure it doesn't go more than half a degree further, or there will be mass extinction of people and civilizations and the world. That's what they're saying. It's a lie. It is not true. That will not happen. The earth has been warmer than it is today through almost all of life's existence. There was no life on the poles, no ice on the poles until 3 million years ago. And now there's been this back and forth of ice coming all the way down to South Dakota and North Dakota and into Washington State and into New York had a big glacier on top of it back 20,000 years ago. And that was only the 40th time that happened during this ice age. So, to conclude, I'll just take us back to the ancient rainforests of the Pacific Northwest, the beauty of that. But I'm kidding you a bit because I took this picture about 300 feet from the house we just left in Vancouver to move to Vancouver Island. This is indeed wild Pacific Coast rainforest. But in around 1925, it looked like this. Now the loggers who cut these trees back then with no chainsaws, they used double-bitted axes and cross-cut handsaws to cut these trees. They didn't replant that any more than my granddad planted the trees he cut in the 20s and 30s. They just left it. And today, Pacific Spirit Park, which is the largest urban park in North America, it's 2,000 acres of wild forest, is all grown back into beautiful Douglas fir, western hemlock, western red cedar, and all the other species that are typical of the West Coast rainforest. All the beauty has returned to it, the fertility of the soils. Where you see sword ferns, you know the soil is healthy and fertile. All of the biodiversity, except the big mammals aren't there. There's no cougars or bears, but there are coyotes and owls and eagles and pileated woodpeckers and a whole bunch of different species in there, everything except the big mammals really, but it's an urban park, what do you expect? And it is absolutely certain that if forests will grow back like this by themselves without any help from people, with our growing knowledge of silviculture, soil science, biodiversity conservation, and all these subjects which we have learned so much about just in the last 50 years or so, we can make certain that the forests of this world will provide an abundant and hopefully growing habitat for all the species that depend on forests for their survival, just like we do, and hopefully an abundant and growing supply of wood to provide us with the most renewable material on Earth for the future. A world without forests is as unthinkable as a day without wood. And think about that. Try and go a day without wood. You can't do it. We have to teach people that. It's a balance. It's not black and white. Teachers have to learn this. Politicians have to learn this. Students, activists, everybody has to learn this, that a day without forests is as unthinkable as a day without wood. We must preserve the forests of the earth for what they do for the biodiversity and cleaning of the air and the water and all the other things. And the best way to do that is to grow trees rather than remove them and put something else there. So that's my story, and I'm sticking to it. Thank you very much. Wood is good, trees are the answer, and may the forest be with you. Well, I try my best to be provocative and to present the case strongly, so I hope that has instilled some questions and thoughts in you tonight, and that I'll take some of those questions and thoughts at the moment, if you have some. Oh, by the way, I wrote a book, and it's on Amazon.com, either as a Kindle for less than $10 or as a paperback for more than that. But it's there. Yes, sir.
So, our good Senator Wyden tweeted today about the hurricane coming into Florida and how climate change is really references a New York Times article that talks about 3 warmest years on record for the last 3. You were pretty definitive in your charts that that's not actually the case. So, when you hear folks talking about climate change causing radiation, hurricanes, and growing size of really warmest years on record for the last 3.
Well, it is true that in the last, say, 2 decades, the average temperature has been warmer than it was in 1880. Because we're in the modern warm period. This is a warming period. It's 300 years on since the Little Ice Age more or less peaked, or you might say reached its nadir, its lowest point, in about 1700, coincident with the modern minimum, which was a solar minimum. So it's thought that that exacerbated it. Whether it was the main cause or not, we don't know. But there's been, ever since that happened, there's been the idea that solar cycles are intimately related with the temperature fluctuations, and many scientists believe that to be the case. Of course, the sun is the main cause of the climate. If you took away the sun, CO2 wouldn't be much use as a warming agent. It started with global warming, the cause being carbon dioxide as a greenhouse gas. Water is almost never mentioned, even though water is actually responsible for at least 90 and probably more like 95% of the greenhouse effect. So CO2 is actually a very minor greenhouse gas at only 0.04% of the atmosphere. Water is between 1 and 4% of the atmosphere, absorbs infrared radiation across a wider band than CO2 does, and is therefore at least 95%, because it's 25 to 100 times more concentrated in the air than CO2 is. But it's never mentioned. Even though it is the primary greenhouse gas, that is a fact. There is no question of it. All that is very well documented. So to say that CO2 is even the cause of the temperature increase in the modern warm period is a complete and absolute stretch. There is no evidence for that. None. They just say CO2 is a greenhouse gas, it has warmed, therefore CO2 is the cause. ignoring water vapor and water. Because water as a liquid in clouds is also a greenhouse liquid. It's not a greenhouse gas because it isn't a gas, it's in liquid form. But droplets of water absorb infrared radiation and re-radiate them. It's not reflection. People think that clouds reflect the heat back, and that's why it doesn't cool as much on a cloudy night as it does on a clear night. But that's not why. They're not a mirror. And infrared radiation doesn't act with mirrors. Anyways, what happens is the water vapor in the clouds absorbs the energy that's coming up and then re-emits it downwards, because the part of it that it re-emits upward has clouds above it too, so it's a big blanket. But it's not a blanket in the sense of preventing convection, which is why blankets keep us warm, basically, because they prevent the heat from escaping from our body into the air by being a barrier to convection. Whereas clouds that's not how they work. I recommend all of you to read Richard Linson's lecture to the Global Warming Policy Foundation. It was 3 days ago in London at the Global Warming Policy Institute in the Institute of Mechanical Engineers building, which is right in the center of London with the 10 Downing Street and Westminster and everything, and Buckingham Palace all around it. Very prestigious lecture. And he basically points out that one of the reasons average people get that climate change is not real in the way that they're talking about it is they're not in the elite where they can just afford to do any of this stuff. Well, they could afford to, except it turns out that most of the extreme anti-fossil fuel people in the elite are using more fossil fuel than the average person, like by 20 times if they have private planes and leave their limos idling while they're in their A-list events and all this stuff. I mean, it's just ridiculous what's going on at that level. But, get back to the science again, there is no evidence that extreme weather events have been caused by climate change. Whatever climate change is being caused by, which is what they mean is warming. So started as global warming. There's no way that CO2 causes hurricanes, unless you think the hurricanes are being made stronger by warming, which is the exact opposite of what you would expect. Because when the Earth warms, it warms more towards the poles. That's why there were forests on the North and South Pole before this ice age came, because the poles were not as different in temperature from the tropics as they are today. There's about 30 degrees Celsius or more difference between the poles and the equator. It was closer before, and hurricanes are caused by the difference in temperature, known as delta T, between the temperate air and the tropical air. That's why hurricanes happen at that latitude. It's the cool air of the north and the warm air of the tropics meeting and creating those cyclones. One would expect a warmer Earth would have actually fewer hurricanes than a cooler Earth does because of the difference in temperature. So it went from global warming, and then when it didn't warm very much anymore after the year 2000, they changed it to climate change. So now anything that changed could be attributed to CO2. Droughts, floods, hurricanes, tornadoes, you name it. And then when you said, yeah, but it was really cold last winter, they would say, that's not climate, that's weather. You can't confuse weather with climate. What do they talk about now? Nothing but extreme weather. Extreme weather is normal. It always has been. And I have challenged on my Twitter account, where I have 26.7 thousand followers, which goes out, a couple of my tweets lately have got over 200,000 hits of people looking at them, and it's a group of people that I've gathered over the last 3 years, all seriously discussing this issue. Every once in a while somebody comes in and says, you're full of crap, and you just have to deal with that. But mostly I've got people who are interested in the subject there. I have said over and over again, name me one factor in weather and climate that is out of bounds with the last 10,000 years of weather and climate. One thing. Oh, the glaciers melted tremendously after each of these after each of these cold periods. The glaciers are melting now, but they melted after the medieval warm period too, and after the Roman warm period, and after the Minoan warm period. Glaciers are actually advancing now compared to what they were 5,000 years ago. You saw the chart there. Which chart?
If you go back to your chart of the geologic history of the
Yes.
you connect CO2 with temperatures. So did you connect the position of the continents? Did you connect the language cycles?
I'm just going to try to find out which one you mean, because they're all different time scales. Do you mean this one? This one? Yes.
Did you ever overlay the position of the continents during the geologic period? Where the continents are relative to each other affects the way light gets reflected from the planet.
Yes, it could theoretically reflect the temperature, but not CO2.
Where the continents are on the planet affects how much light is reflected, and where the planet is relative in the language cycle also reflects how much heat it absorbs from the sun.
This was not due to continental drift. It's too short a time.
But my issue would be that some of these cycles, you're trying to connect the cause and effect to these two things without this chart is not taking into effect all the other external.
No, I'm not trying to find out the cause and effect. I'm showing you how there is virtually no evidence of a steady synchronous between the two. There is no evidence of a strong correlation here. I don't know which other effects you're referring to. No, there isn't. That doesn't change these parameters at all. Those parameters are what they were at that time, regardless of where the continents were. That's just where they were. They both happen. These two things here, this coming down while this goes up and this going up while this comes down, the exact opposite of what you would expect from a causal relationship, happened simultaneously with each other. They didn't happen at different times. They happened at the same, this time and this time are the same, this time and this time are the same, this time and this time are the same time. And so it's a time sequence of the relationship between CO2 and temperature. There were many other factors going on during this time, like thousands of them. But when you tweeze out these two, you can see that there is no clear relationship between CO2 and temperature.
So I come from a geology background, and I look at the evidence, and I obviously disagree with your interpretation, but let's say I'm right.
No, not interpretation of what? What is your evidence?
Well, I've looked at the increases in CO2, and I actually don't think
That's a political position. It's actually resistance from behind for those of us who are trying to make some sense out of this. That's one of the reasons Tillerson was let go, because he also agreed with that position. They're basically saying, shoot me in the face, please, and then I'll be okay. But you're talking about just this period. Are you not just talking about this period? The increase in CO2? Because this is the only time that increases CO2 has happened since 150 million years ago.
Yes. But my question is, if my interpretation of the data is correct, and
Which data?
of the weather changes and the climate change is correct,
Which weather changes and which climate changes and which data? People use generalities all the time.
if I believe, based on the interpretation of the changing temperatures on the Earth,
Over which period of time? I showed you a whole bunch of periods of time here and what was happening in, as you,
that by 2040 we're going to have some serious problems, and that perhaps things like Miami are going to have serious flooding.
so you believe they can predict the future climate.
I believe we can make reasonable predictions on it, yes. And if I believe that,
Well, that's what a lot of people don't believe, and I don't believe there is any basis to believe that. Even the IPCC says you can't predict the future climate, and then they disregard what they said.
except that you and I don't agree on this, but if I am right, your only solution you present is the solution to plant more trees. Do you not believe we should at least invest in technology to cover our bets? Because the only thing
Which technology, for example? For example, which technology? Nuclear energy?
I think that we should be investing in infrastructure to help shore up places that are running.
Nuclear energy?
I think we should be investing in storage capacity for alternative energies.
You mean batteries? Enough batteries to back up the US grid? Wind and solar? Wave energies. Now that's getting out there. Most of the wave energy experiments have ended up on the beach. Yes?
So some of our forests are not actually, contrary to what you said earlier, some of our forests in like the Rockies, national forests are not actually sequestering more carbon over time than is being lost. They've actually reached a maximum biomass carrying capacity. My question for you is that the best we can do? That is to say, you throw it on the forested landscape until it stops taking up more carbon? Or is maybe there another step we can take?
I don't believe I said that, but I do believe that we are not waiting until the trees stop growing before we cut them, that's for sure. They're being cut. There's a curve that goes like this, and we cut them here, even though they keep growing beyond that, but it's a diminishing returns issue with time and the economics and all that. So, and I'm not arguing that trees can solve, if you want to solve the buildup of CO2 in the atmosphere, it's not going to happen with trees, because trees are basically net zero. Because every time you cut a tree and turn it into paper and wood products, eventually it decays and the carbon goes back into the atmosphere while you grow new trees. So the IPCC and other bodies who have their science right are basically saying that forestry and forests are net zero. That's why the IPCC says we should be growing more trees, because the more land you have forest, the more carbon there is in the stock. But we can't, quote, solve the problem of CO2 emissions from fossil fuels with trees. The scale is just, like we're putting 10 billion tons of carbon, 36 billion tons of CO2 into the atmosphere each year, which I think is a good thing because we are restoring a balance to the global carbon cycle and giving the plants what they want, which is more CO2 to support their growth, because they're starving out there. That's why greenhouse growers, how many of you are, no, I'll come to you next. How many of you know that greenhouse growers purposefully add double or even triple the atmospheric level of CO2 to their greenhouses in order to promote higher yield and faster growth? That is a worldwide phenomenon. They all know that that's what you should do. And if you put higher CO2 in the atmosphere, it will do that to all the plants that are growing on the earth. Because most of the plants in nature are limited by the CO2. If they have enough nutrients and water and sunshine in a natural environment, the limit on their growth is CO2. So that's what I'm saying. I'm not saying that we can solve the problem if you could perceive it as a problem. The whole idea that we should suck billions of tons of CO2 out of the atmosphere with some technology is completely ridiculous. It's simply not going to happen. The only way we know how to suck CO2 out of the atmosphere effectively is with plants. And that way we don't have to build massive infrastructure of some kind that won't work anyways. And so, yes, ma'am.
When I was watching a lot of your graphs of the, hundreds of thousands of years, hundreds of thousands of years, and I have no doubt that the earth and everything has its pattern. You've shown it up there. But for those hundreds of thousands of years, it was nature doing what comes naturally. And I fully expect nature to keep working to do what comes naturally. But in the last few decades, which wouldn't even make a dot on these great big hundreds of thousand years graphs, some really major things have happened with man-made things and chemicals and pollution. And I'm not saying that proves something or disproves something. I'm just saying that is true and that exists and is separate from hundreds of thousands of years of nature. We've intervened in a different ways. I don't know all what that means, but I know that that is not on that graph till now.
Well, you know, I was focusing almost strictly on CO2 and temperature here. They have not really changed much in the last 100 years except for CO2, right? That has changed quite radically because of our emissions. But I separate that from pollution. It isn't pollution, it's food for life. They're two different things. They love now to take pictures of smokestacks, as they call them, with the backlight so that the steam looks black. They do that all the time and put it on the front page in color to make it look like the steam coming out of industrial facilities is soot, basically. That's what they're trying to make you think of. That's why they call carbon dioxide carbon, because when we think of carbon, we think of soot. We think of black, right? Because carbon black is black. But CO2 is not carbon. It is carbon dioxide. That would be like calling water hydrogen, H2O. Just call it hydrogen for short. Why not? But they call it carbon for short for particular propagandist reason, in order to make you think it's black and dirty. And like coal is black and dirty, right? Fact is, dirt is dirty, and all our food grows in it, well, except for the aquaculture, right? So dirty is a dirty word, actually, because it's used unfairly against a lot of things, like dirt. No, you didn't, but you're mentioning pollution, and that you're right about that. But you know, the United States passed the Clean Air and Water Act and the Endangered Species Act in '72 under Nixon, and those legislations have been in effect all this time and have made the air in all the cities in the United States much cleaner than it was in the '70s. I remember Vancouver, where I grew up, you couldn't see your hand in the terrible fogs that occurred in the fall because the air was full of pollution and particulate. And it's not like that anymore. So we've actually improved in the industrialized countries, and countries like China are now catching up because they are wealthy enough that they can afford the pollution control technologies that do cost money. But when you get wealthy enough and you've already got a refrigerator and a TV and maybe even a scooter, or maybe even a cheap car, by that time you start looking around and thinking, geez, wouldn't it be nice if the air was a little cleaner around here? And you've got disposable income, and you're willing to let that happen in your politics. And that's happened as every country became industrialized and caused pollution. They have fixed it, basically. So I fly over the world all the time, and I marvel at how green and beautiful it is. You know, you fly across the United States, it doesn't look like a junk heap. It looks like a beautiful ecosystem from one side to the other. Even the deserts are healthy. You know, so I don't see this doom and gloom scenario on the planet. No, you didn't, but
A great big change in the last 100 years, and I'm curious how that plays out, and I want us to do everything we could to make it play out well.
I agree. There, I totally agree with you. Yes?
What's your recommendation for managing forests that have been ravaged by forest fire?
Well, it depends what status they were in the first place. If they were in a protected status, most people would argue that they should be allowed to regenerate naturally. If they're in commercial forest production, they should be cleaned up and replanted as soon as possible to get the wood going again. So it depends on what the designation of the land is. Now, I would not be against rehabilitating, say, even in a protected area, an area that was so badly disturbed that it's liable to have big landslides into the rivers and cause lots of fish death and everything unless you went in there and got the soil stabilized. So maybe some intervention is justified under some circumstances. But Yellowstone, for example, when it burnt so catastrophically in 1988, was it? Sometime like that. That was huge fires. It's basically healing itself, and will do so. But it takes a lot longer for nature to heal itself. I showed with Mount St. Helens how if you go in there and replant the area with good trees, you'll get a new forest much faster than you will if you let it regenerate by itself. But if you're not worried about timber production on a piece of land, what's wrong with letting nature take its course and show people how that works too? and have it as an opportunity for people to learn how ecosystems heal themselves by themselves. I don't see anything wrong with that. So again, it depends. If it happens in an area where there's a lot of houses and the houses all get burned up, probably should think of a different way of dealing with the forest-urban interface. Make sure there are no trees near any building in areas like that, like in Arizona, like Flagstaff is a classic case of a place where you have very dry coniferous forests and lots of people are living in them. And in those situations, you should make sure your house has a steel roof rather than a wooden one, for example, and a whole bunch of things. You want to be protected from your house burning down in a wildfire. And the best way to do that is to make sure there's nothing flammable within 500 feet of your house. And even then, a crown fire will come right through. So that's a serious issue, the issue of the urban-forest interface and fire. And it's not the simplest thing to sort out. But there are lots of things that can be done to make it less likely that your house will go up in smoke if there is a fire in your vicinity. Yes?
So why do we have climate change narrative, and how long does it last?
Oh, I don't know. It's such a money machine. There's over $1 trillion now being spent, mostly public money, being spent on the climate subject. And so if you don't conclude that there's a problem that needs to be addressed, if you don't conclude that more study is required, then why would they give you any more money? So it's self-perpetuating in that sense. The IPCC, for example, presents itself as a scientific body. It is not. It has scientists. It pays them. It is a political body that pays scientists. And its whole purpose is to investigate the human cause of climate change, not the natural cause. That's in its charter. So it is inherently conflicted from the start to find on the side of apocalypse. Because if the IPCC came to the conclusion that humans are not the main cause of climate change, or that even if they are, it is not a disaster, in fact, it is a good thing to get a little bit warmer with a little more CO2, or even a lot more CO2, then there'd be no need for them to exist. And that's the way politics works. It's a self-serving setup from the beginning. And you can see, I mean, that's the way it works. First, the United Nations is a political organization, not a scientific organization. And the IPCC is a merger of the International Meteorological Association, which is also a political organization. All these associations, like labor unions and professional societies, are all political organizations looking out for their members. The Society of Engineers doesn't do engineering. They look after their engineer members. That's politics. They are lobby groups, not scientists. And most of the science journals have been taken over by journalists, mostly by journalists who are in league with the narrative on climate change. The BBC just formally barred anybody who's skeptic of the narrative from being on the radio in England. It's a written policy. It's been done by many newspapers. The Los Angeles Times did it quite some years ago. Said they would not present any skeptical position on the so-called narrative, which if you read Richard Linson's speech, you will see, how many of you know of the name of C.P. Snow? Anybody know who C.P. Snow is? He wrote a book called The Two Cultures in the 50s. It was about how the arts and sciences had diverged into two cultures. And the people on the liberal arts side did not understand very much about science. And so what you have to do for those people is to invent really simple narratives, and then they'll think they understand science. If you say to them, CO2 is the control knob of global temperature, NASA, the extreme side of NASA, which is based in New York, not in the space station place. The New York base of NASA actually on its website has a picture of one of those circular thermostats that go on the wall with CO2 written in the middle of it. As if we actually have a control knob. They have actually used the words control knob to describe CO2 and climate and the relationship between the two. If that is not a simplistic narrative, I don't know what is. Because obviously there are many other factors affecting the global climate. Because before CO2 came along, or before we started emitting large amounts of CO2 and restoring some CO2 to the atmosphere after it had declined for 150 million years in a steady fashion, before we did that, the climate was changing so much more radically than it has changed in the last 150 years, it's not funny. It has hardly changed at all in the last 150 years. It changed quite a bit coming out of the last glaciation, from when the whole of northern North America was covered in a mile or two of ice. That was quite a big climate change. And the sea rose 420 feet during that process to where it is now. And during the previous interglacial, it was 10 or 20 feet higher than it is now, because it was warmer during the Eemian than it is in the Holocene. And basically, if you saw my chart there, I can get back to that pretty quickly. This one. The reason I drew these two lines is to show that we are actually only 2.5 million years into the Pleistocene Ice Age, still descending into a colder world overall. That's what the ice cores show us. This was colder than this was colder than this. We are still entering the Pleistocene Ice Age. And we are coming out of the Holocene, about to go back into another slide like this, if history repeats itself, which it has done, proven for at least 8 times on this 100,000-year cycle. What more do we need? I use history to judge what's going to happen in the future, more than made-up stuff about the future. They say the Holocene is over. They say the Pleistocene is over. They say we're now in the Anthropocene. Thankfully, the International Committee doesn't buy into that, because it's a fake hoax. The Holocene is not over, but we are towards the tail end of what would normally be a 10 or 12,000 year interglacial period from history. And now we are beginning this slide in conjunction with the tilt of the Earth changing and CO2 having gone up rather than down, which one would have expected it to do in a cooling Earth, hence the conundrum. There are many conundrums in the history of climate. One of the key ones is why it changed from a 40,000 year cycle to a 100,000 year cycle about 1 million years ago in the middle of the Pleistocene Ice Age. At first it was following the tilt, and suddenly it changed and started following the orbit change, the 100,000 year cycle here. Here. This is real. This is from the Vostok ice cores with real data measured from real bubbles in real ice cores. So that's my evidence right there. One more question.
The second part of my question is, how long does the narrative last?
Oh, that.
Does science count politics, or?
My dad told me never count politicians and labor leaders out. I think it applies in this case. I think the politics of this situation is so powerful, and there's so much money in it. But there's a crack in the dam. It all started here in the United States, and it's spreading to Australia and Poland and France. And of course, half the world's population, which is composed of China, India, and Russia, never bought into any of this narrative in the first place. The Russians think it's the sun. They've been focusing on the sun in the International Space Station the whole time it's been up there. They're the only buddy who can get us up there now. They're real smart. They're way far ahead of the United States in nuclear energy technology now, way far. They're building fast neutron reactors on the Caspian Sea and proving that we can use all the used nuclear fuel for thousands of years into the future as fuel rather than thinking it's waste. And the Chinese are doing the same thing. And India is basically building 30 nuclear reactors too, right now. Whereas the United States is basically stalled for the last 30 years on the subject, even though it has more nuclear reactors than any other country. But if any sane person really wanted to reduce fossil fuel use, especially for electricity production, which is a big amount of coal in particular, and gas, a huge amount of coal and gas is used for electricity production. That could be substituted with nuclear energy in 10 years with a massive build-out. No civilian has ever died from nuclear energy in the United States or in any other country except the Chernobyl disaster, which was a nuclear design that should never have been built because it had the potential to go critical, which none of the other reactor designs do. They have the potential for a meltdown of the core with loss of coolant, which is what happened at 3 Mile Island and Fukushima. But in that case, nobody died in either of those incidents. Those weren't disasters. They were just really expensive incidents. 3 Mile Island wasn't even that expensive, but Fukushima was really expensive because they really screwed up, both before in the design of that thing and after in the follow-through during the meltdown. They just messed it up so completely. It's unbelievable. There's still no report out on that because the insurance companies are still bickering. So we have never actually had the true story of Fukushima. But what we do know is they should never have evacuated the people, the citizens, from around the plants because there was not enough radiation to warrant it. And they killed 1,600 people by moving them. In particular, they moved an intensive care ward into a gymnasium. And many people died as a result. So the World Health Organization knows, just like with Chernobyl, where they moved 350,000 people into tenement blocks around the city of Kiev, where the rate of murder and violence and drugs and beatings and child abuse and every other thing that occurred in a group of rural people who were put into these tenement blocks was so much worse than anything that ever could have happened from radiation. And in fact, a follow-up study that has been done over the last 30 years on those people shows there is no increase in any cancer in any of those people, because even though they were quite heavily radiated, they weren't radiated like the people in the Hiroshima and Nagasaki bombs, which were also followed up for their whole lives. 100,000 people who were survivors from the Hiroshima and Nagasaki bombs, along with 20,000 people who lived in those towns but were not there that day as a control group, were followed all their lives. There's almost none of them still alive, but they didn't die very much prematurely. There was like a 1% change in longevity in the people who were severely radiated and survived versus the people who were not radiated at all. So our fear of radiation is just completely ridiculous. You know, the sun, for example, that's radiation. It's a slightly different kind of radiation, but it is radiation. And if you go into the sun for half an hour, you're fine. You get a lot of radiation in half an hour. You go into the sun for 8 hours naked, you're liable to die. Right? It's the same with nuclear radiation. It's all in the dose. It's not just the fact that it's radiation. So if we wanted to actually reduce fossil fuel consumption for energy, by far the best technology because it's universally applicable, unlike hydroelectric, which is beautiful, but it only works where there's the right terrain and rainfall. So it doesn't work in Saudi Arabia, and it doesn't work in Denmark, even though there's lots of rainfall, but it's perfectly flat. So you have to have a hill somewhere. Whereas nuclear energy can be established anywhere in the world. And I'll just end with that because I think the biggest mistake the environmental movement made in the 70s and into the 80s was to confuse nuclear energy with nuclear weapons. Instead, nuclear energy should have been grouped in with nuclear medicine as a beneficial use of nuclear technology. Thank you very much again, and I'll see you outside for some tea.